After learning the chord properties of a circle, now we come to the angle properties of a circle. For a circle, we usually talk about two kinds of angles. The first kind is called the angle at center. That means the vertex of this angle is at the center of this circle. For any angle at center, it is subtended by an arc, like this. The other type of angles is the angle at circumference, which means the vertex of the angle is on the circumference. Similarly, the angle at circumference is subtended by an arc as well. Now take a look at this diagram. Here the angle at center and the angle at circumference are subtended by a same arc. And now the size of the angle at center is double the size of the angle at circumference. When we change the size of these angles, as you can see, as long as these angles are subtended by a same arc, the angle at center must be double the angle at circumference. This property is known as angle at center twice angle at circumference. To prove this property, we need to consider the following three cases. Let's consider the first case. Here we want to prove that y is equal to 2x. Because the radii of this circle must be equal, therefore this is an isosceles triangle and hence these two base angles are equal. By considering the exterior angle of a triangle, y can be shown to be equal to 2x. As a result, the angle at center is twice the angle at circumference in this case. For case 2, in order to prove that y is equal to 2x, we can draw a line passing through the center. After this, these two angles x1 and y1 are just the angle at circumference and the angle at center in case 1, and therefore y1 must be equal to 2x1. Similarly, for these two angles x2 and y2, they can also be regarded as the angles in case 1 and we can draw the same conclusion. Now if we consider x to be the sum of x1 and x2 and y to be the sum of y1 and y2, it can be easily deduced that y is equal to 2x. That means the angle at center is still twice the angle at circumference in this case. Finally, for case 3, to prove that y is equal to 2x, we also need to draw a line that passes through the center. When we consider these two angles, x1 and y1, they are the case 1 angles, therefore y1 is equal to 2x1. On the other hand, when we take a look at these two angles, x2 and y2, we can draw the same conclusion that y2 is equal to 2x2. Now we know that x is the difference between x2 and x1 and y is the difference between y2 and y1. As a result, we can conclude that y is equal to 2x. That means the angle at center is twice the angle at circumference. Therefore, we have proved that this property is true for all of these cases. Now let's think about this. If the angle at center is a reflex angle and the angle at circumference is x, what is the value of this reflex angle? Can we still apply angle at center twice angle at circumference when we have a reflex angle? If we consider a line joining the center, we can see that this case is actually the same as case 2, even though we have a reflex angle in this case. Therefore, it is still true that the angle at center is twice the angle at circumference, and this reflex angle at center should be equal to 2x. To conclude, when the angle at center and the angle at circumference are subtended by a same arc, then the angle at center is always twice the angle at circumference. Now let's take a look at a special case like this. If the angle at center is 180 degrees, obviously the angle at circumference should be half of 180 degrees. That means 90 degrees. In other words, when the angle at circumference is subtended by a diameter of the circle, this angle at circumference must be a right angle. This property is referred as angle in semicircle. On the other hand, if the angle at circumference is 90 degrees, that means the angle at center must be 2 times 90 degrees, which is 180 degrees. That means when the angle at circumference is 90 degrees, the chord subtending this angle must be a diameter of this circle. This property is referred as converse of angle in semicircle. Besides angle in semicircle, we have another property of circle based on angle at center twice angle at circumference. If this angle at center is 2x, that means this angle at circumference is x. However, if we change the position of the angle at circumference, it should still be x. That means these two angles are always the same, and the property is referred as angles in the same segment. We call these angles in the same segment because these two equal angles can be treated as angles in this segment. Take a look at this diagram. As you can see, no matter how I change the position of the angle at circumference, as long as it is in the same segment, its value remains unchanged. When it moves below this chord, the size of the angle changes because now it is in a different segment. However, in this minor segment, the size of this angle also remains unchanged. Let's have a quick summary. In this video, we have learned that the angle at center is always twice the angle at circumference. Based on this property, we can derive three more properties of circles. First of all, we know that a diameter always subtends a right angle at circumference. This is known as angle in semicircle. Conversely, when we have a right angle at circumference, it is always subtended by a diameter of the circle. And this is converse of angle in semicircle. Lastly, we know that the angles in the same segment are always equal, no matter this is a major or a minor segment.